In this video, we are going to see about complex integration. First, let us know about what is meant by complex integration. So, it is the integration of a function with complex variable. That is, here we are considering a function w is equal to f of z. Let it be a continuous function of complex variable. Here, z is said to be a complex variable which is represented as x plus iy along a curve capital C with endpoints A and B. That is, here let us consider a curve. This is to be the curve C and the endpoints are considered to be A and B. Okay. So here we are going to integrate this f of z dz over the closed curve C. Actually here this symbol represents closed curve C. Here it is an open curve. Closed curve means it should be closed. Okay. So this is the curve C. So here we are defining the integral over C f of z dz is equal to integral over C u plus iv into dx plus I dy. Okay, so here f of z is nothing but here w is equal to f of x plus iy, because f of z is equal to f of x plus iy. So this can be written as, depending upon the function, here we can able to split it into real and imaginary part. So the real part of the function is considered to be u and imaginary part of the function is considered as v. So that some cases w is defined as u plus iv. So that here f of z, that is w is nothing but f of z, so that we can use f of z is equal to u plus iv. So here we have replaced f of z is equal to u plus iv, and then dz is what? Z is already x plus iy, so that dz can be written as dx plus I into dy. So that here we have replaced dz as dx plus I dy. So this is known as complex integration. So using this we can able to integrate a function in terms of complex variable along a certain curve. If it is an open curve, the endpoints will be considered as a and b. If it is a closed curve, just the curve is represented as c. Now let us see the example. Evaluate integral over C z bar dz from a to b. That is, a is the point 0, 0, the origin, and b is the point 4, 2 along the curve C, and z is equal to t square plus it. So here we have to evaluate this. So here it is given that z is equal to t square plus it, which is nothing but z is equal to x plus iy is the general notation. So that here, which means that x is considered to be the real part t square and y is considered to be the real part, sorry, imaginary part t. And moreover here we have to integrate z bar dz. So since z is equal to x plus iy, z bar is nothing but x minus iy. So that we have to integrate this x minus iy. It's here dz is equal to represented as dx plus I dy. So we have to substitute both in the given integral, so that here integration z bar dz is equal to integral this z bar can be replaced as t square minus it, and then instead of dz here we have evaluated as 2t plus I into dt. Why it is 2t plus I into dt? Here already I told you that x is equal to t square, y is equal to t. So that here dx can be written as 2t dt and dy is equal to dt. So here from this dz is equal to dx plus I dy. So that here dz is equal to dx can be written as 2t dt plus I into dy is dt. So this is equal to, we can take dt as common, so we'll be having 2t plus I into dt. So dz can be replaced as 2t plus I into dt. That is what here we are having. So now we have substituted, but what are the limits for this variable t? So here already we have seen that x is equal to t square and y is equal to t, which means that y is equivalent to t. So if you know the limit for y, we can consider the same as the limit for t also. So here the points are 0, 0, to 4 comma 2, which means that this is x and y, this is x and y. So x varies from 0 to 4 and y varies from 0 to 2. So that is what here we are having. X varies from 0 to 4 and y varies from 0 to 2. Since y is equivalent to t, we can conclude that t also varies from 0 to 2. So that is the reason here we have taken the integral as 0 to 2. So here, since we are having the integration everything in terms of t, the limit should varies only for the variable t. So since here t varies from 0 to 2, we can substitute the limit as lower limit as 0 and upper limit as 2. And then this, just by usual multiplication, we can multiply this term and integrating with respect to t and applying the limit 0 to 2, that is upper limit minus lower limit. Finally we will get the answer as 10 minus 8 by 3 into I.